All right, stats, chapter 8. Let's begin with a simple discussion. What is your guys' interaction with statistics? Spreadsheets. Okay.
When I did statistics, we mostly did like word problems, stuff like that.
Okay. But give me applicable examples of stats in your everyday life. There we go. That's better, Travis. Define the question better.
Like accounting, like having their job, would that be?
Like an accounting and their job. Is that what you just
No, I
said?
said accountant.
Okay, like an accountant. No, that'd be more accounting.
You said stats.
Yeah, statistics. What are some real-world examples of statistics?
Fantasy
Politics.
Partial. We'll talk about that. What was that?
Politics.
Politics. What about politics?
I don't know. I know, like they deal with like so many like something statistic to. I don't read the news.
Wow, did Nick just give that answer? That was a horrible answer.
Hey,
It's politics. Like they deal with the things that do the one things, you know, like South Africa and the Iraq. Not everyone has maps. Okay. Politics. Okay, well, we're in politics. Do we see it? We see it in polls, poll questions.
That thing, yeah.
Well, they'll say, hey, said individual is running for president. Look at this guy.
I'm fashionably late.
Apparently.
Yes.
I'm not gonna lie. It was me. It was Pizza Hut. Me, my pineapple juice, and a female. That's what had me caught up.
Nice.
What?
Me, Pizza Hut, my pineapple juice, my food, and a female. That's what had me held up.
Polls. So polls, what they do is one of two things. They go out and they say, hey, yeah, what is, what?
There's a lack of people here.
I know.
No
Because
dicks
either
show
everyone's
up.
sick or everyone's on the road right now.
Oh, really?
Yep.
Damn. Okay, proceed.
Oh, sorry. I didn't know I got the,
And you take authority from him.
I know. That was interesting. I have the con, I guess.
May you have a lead.
I said may I.
Now,
Technically, you don't
if we focus on this,
I said hi. It's not my
if
fault.
we focus on this, we get out of here a lot quicker tonight. Just saying. By the way, this is being recorded, so I'm just saying it one more time. So,
Will this be important?
yes,
It's for everyone who's not here.
it's for everyone who's not here.
Oh.
Hey, everyone, D said that. So yeah, polls. We use it for polls, okay? That idea of, I have a group of people, I want to know what their opinion is. Who are you voting for president? Who are we, what's your opinion on, you know, hey, what's your opinion on abortion? What's your opinion on this, right? It's
What
just,
is your opinion on abortion?
that's not here nor there right now. Or, you know, what's your opinion on this? What's your opinion on that, right? So that they can gauge public opinion. All right, what else? Actually, Nick had one, actually. He said
Fantasy football.
fantasy football, but more generically, I will say sports. Where do you see statistics at in sports?
How they're doing, like throughout like the seasons.
Performance, both individually and then also as a team. Okay? Does anyone watch baseball?
No. I played it when I was a kid.
Okay. When you watch, actually, there's two things that jump out real quick when it comes to baseball: batting average.
And then throwing pitching speed.
Maybe. Hold on, we'll come back to that. Batting average. So if they come back and they say someone has a batting average of 0.312, what they're saying is their success rate for hitting is 31%. So every time they've been up to bat, 31% of the time they get a hit.
That's bad.
That's really bad.
Okay. By the way, the highest all season, if I remember correct, batting average goes to Ted Williams, which was .402, if I remember right. On average, that's actually pretty decent. Average is somewhere in the 20s.
What?
But they like have to hit the ball when they look.
Wait, this season? This season or?
All time, Ted Williams.
How old is he?
He's dead.
Oh.
Okay.
Bluffing.
Where else do you
I knew who Ted Williams was, but I didn't know he had the world record.
Yeah, I said he had the best
I mean, he has the best.
hitting average in a season. He should still.
Okay.
Where else in sports do you see statistics?
Soccer.
No, I'm saying sports generically.
Oh, generic.
Yeah, generically.
Not.
Not just a sport, but like, yeah. Where else do you see it?
Catching average?
Okay. Man.
Football, mostly. Rugby, football.
Okay.
For soccer, it would be pace, to determine if your pace and stamina.
Okay.
And
Speed.
then
Hockey would be goals.
Yeah. Save percentage, win percentage,
shot
stuff like that.
percentage.
Right, yeah.
Um,
Those are averages pretty much, or the idea of total numbers, percentages, all that other stuff.
UFC would be with,
Volleyball.
what is it?
No, like what would the average?
KOs to TKOs?
Negative.
Not?
No, I'm just saying, I don't know. Oh, I thought you said an individual. I'm sorry, my fault.
What would the statistics of volleyball be?
Don't know.
probably
Also, I never
serve.
watched it, so.
But, so a great example, if you watch baseball, what they'll do, or actually any of the sports now, they'll say Team X, you pick whatever team it is, and they'll say not only this is their performance so far this year, but in the last 10 times Team X has played Team Y, they have won 3 games and lost 7. Or the other way around. Or meaning that if you watch sports, they give you statistics on just about anything these days. Right? To the point where it gets this batter is 3 for 10 in the last 10 appearances at night. I'm not kidding you. Right-handed pitchers at night. Why? Why are they doing that? Why are they giving you those statistics? Why are they telling you that?
For,
Information.
Okay, they just put it out there, just like,
Not
hey guys,
just-
we noticed.
no, it's for the, it's for like scouts and stuff like that, so they can see the percentages.
Okay, but why? Why for scouts then?
To recruit them for another team or sponsor them.
Okay, but why?
For the generic brand, like for like say Kobe Bryant for Lakers,
Okay,
like his image was like a big thing for Lakers.
okay, but why?
They don't want to bring on a sucky person to their team.
Exactly, it's performance. You're watching a game, okay? You're watching a game. Let's say you're watching baseball. Baseball is a little bit slower, so you got time to actually think about what's going on. Versus, football, you have a little bit of time. Hockey is just keep going, etc. But it's trying to use numbers and facts to predict performance. Okay, stop and think about it. If I get up and there's a batter up there and they say, this individual is batting average versus the right-handed pitchers is only .312. What are they saying? And the pitcher is a right-hander.
He's
So,
a good pitcher.
No, he sucks right-handed.
yeah, so you're saying his right hand.
No, you guys are missing it. I'm the batter.
Okay,
Derek is the pitcher.
got you.
All right? And they say Travis's hitting average against Derek, who's a right-hander. Sorry. Or the last 10 times he's been up to bat against Derek, he's gotten 2 hits, struck out 5 times, and has 3 walks.
Then the right-handed pitcher is a good pitcher.
He's asking for the average for the batter.
No.
What?
He's saying
Are you
that
asking
you
that-
missed the right-handed pitcher. So if he was left-handed, he would probably have a different average if he was. pitching.
No. Why they give you those stats is they're telling you.
Confused.
Why they're telling you that is they're trying to tell you, hey, this is how he's done in the past. We're trying to predict his future performance.
Oh.
This guy sucks.
Okay?
Yeah, he's still gonna suck.
Okay, so the thing is, you're looking at the batter, not the pitcher in that case. Okay? You're looking at that individual. Okay? What are some other examples of stats that you see in society?
Test averages.
Okay, not sports. Get away from
No,
sports.
like
You get,
tests.
oh,
like
test
in
average. I think
school.
catch averages. Like, get away from sports. You guys don't understand this. So I'm trying to find something else.
I
No,
understand
like
soccer.
when you're
averages.
taking tests, like say like 3 out of 10 failed the test, so they take that into like, their teaching skills and they change it.
Okay.
Or
They have their
this class
teacher
had-
meeting every,
Uh-huh.
every
this whole class of eight
1,800, like out of the total of 1,800 kids, there was a 70% success
Bell
rate
curve.
for,
Have you ever had a teacher say, I'm going to grade on a bell curve?
Uh-huh.
What does that mean?
He's gonna take the highest score and then add to whatever they missed to make it a 100, so that they curve your grade to make it higher.
Actually, the teacher's giving you a wrong description of what a bell curve is. Believe it or not. So a great example. What he's saying, or he or she is saying by definition, is I'm going to take the highest grade performance, just add points and scoop everyone up. That's not a bell curve. That's grading on a curve. Grading on a bell curve, which, by the way, if they're saying grading on a curve, that's not even right. That's the thing about it. Grading on a bell curve says, hey, I'm going to make sure that 95% of my students fall in this range right here. That there will be Fs in the class. I will make there be Fs in this class.
Ouch.
I feel like people, I feel like there's a lot of professors that actually
Did you
do
grade
that.
the last quiz?
Not yet.
Oh,
I will make there be Fs in this class.
that's very
Okay.
sad.
You shall not pass.
So yeah, bell curve is another example right there for statistics. So why do we have statistics? Why do we have statistics? Okay.
To improve from the past
Because
mistakes.
people want to be smart.
What?
Imagine for a second.
What did you do?
Alright, I'm imagining. Hey guys, we're imagining. Stop.
Yeah, I believe.
Imagine for a second that amorphous blob represents a population. Let's say for 1 second it represents the U.S. population.
Got you.
It's very small.
Okay? So whatever characteristics, however it looks, whatever characteristics, ethnocentric, performance, like wealth, job, where they live, everything. Just say it's just every single person that we can think of, which is roughly right now what, 325? Is that it? 330, somewhere around there. I don't know what it is these days.
So what?
Let's say it's 330 million.
That's a lot of people.
All right.
Alright, yeah, I'd say that was right, because the last one I checked was like 300.
Let's say hypothetically for 1 second we want to ask the question of how many TVs does an American household have?
At least one.
In an average of American households, I'd say, considering the families that whose houses I've been in, I'd say at least 3 to 4.
The only
TVs.
families that I've been in, they've only had one TV and then a giant theater in their basement.
What place have you been in? What states?
So
What states do you go to?
it doesn't matter where
No,
they
yes, it
live.
does.
No,
Yes,
it
it does.
doesn't.
Yes, it does.
No, it doesn't.
Yes, it does.
Oh my god, Daddy, you're so sweet.
Just tell me what state.
Are you guys done like that?
Yeah.
Okay.
I'm actually happy that you have adults in your
Alright.
class now.
So if that represents 330 million people, we want to ask, what is the average household? How many TVs does the family have? How would we do that?
You would take a survey or do a poll,
Okay.
and then people would answer and say how many they would have, and then you would take that information that you got, and then
Why would we do that?
because then you would get the average amount of TVs per American household that you were trying to figure out. in the
Okay.
first place.
At least the ones that actually answered the survey.
Roger. What is the number one priority of business?
Make money.
Yeah.
The what, Nick?
Make money.
Make money. That's right. Make money. Okay. What are the 2 most valuable resources in the world?
Money
And?
Time.
land.
Time. Time and resources are the 2 most valuable things that you have in life, right?
Yep.
Time and resource. Okay? We want to know, let's say maybe it's not TVs, maybe we want to know something more important. Or we ask, hey, we're going to leave it up to Americans. And go, we think that we should, I don't know. We should kill all children under the age of 5,
Holy crap!
starting next Tuesday.
Why?
That's a great idea. I go for it.
What the hell is wrong with people?
Okay? What if we said that? Now the
There
question
would
would be,
be a
we're
lot
gonna
of
leave.
riots.
Now we're gonna leave that up to a vote.
Okay.
All right, we're gonna leave that up to a pure democratic vote, and we want to know before that vote how America thinks. Okay, so by definition, it would be all eligible people who could vote. So in this case, it'd be 18 and older. The number would go down. But then, how do we? So if we stop and think about it, we want to know what the results are, right?
Yeah.
Okay, before it actually happens. So that's why. So the easiest way we could do that, there's actually the most accurate way would be to do what?
Broadcast it on the TV.
No.
I don't know.
The most accurate way of learning what Americans believe on this topic,
They take a small group of people and do a sample test study.
we would ask every single person in the United States. Meaning we would go to every single person who can vote, and we would say, hey, what is your opinion on this topic, yay or nay?
I was gonna say that, but then I thought it would sound stupid.
No, not at all.
Okay.
All right, but there's a problem with that problem, right?
Yeah.
And what's that problem? I wrote it on the board.
You don't have enough time or resources to do that.
Exactly right. You don't have time and you don't have resources to do that. Okay? Because you have to pay people to do this, right? 300 million people. You have to find every single person.
That's a lot of people.
That's a lot of people. That's a lot of time. It's a lot of effort.
And a lot of people travel.
Yep. And then you have.
I've only seen it in the country.
And then you have money on top of that. Okay? So it's not very practical. So statistics allow us to, just as we've been studying here, to come in. And what we can do is, like that little kidney bean I just drew there, kind of, is just like Miranda said, we can go out and, in order to save time and money, we can create a sample. We'll go out and sample people and ask them their opinion. So instead of asking 300 million, maybe we can ask as many as just 1,500. Okay? Here's the linchpin. Linchpin to the entire argument. It's called the central limit theorem. Central limit theorem says if you have an adequately sized and characterized sample, all right, and you identify a characteristic about the sample, and the sample represents the population by race, gender, whatever it is, you can therefore say whatever happens to the sample happens to the population. Okay? So instead of asking 300 million, you can actually now ask 1,200 people. But you have to account for a lot of variables. Okay? So for example, when you, at the first phone survey I ever had to do was in when I was 22. I was living in Wyoming at the time. Take that back. Yeah, I was 21. It was 2000. I got a phone call on a landline at the time asking me about Bill Clinton and asking my opinions. The questions they asked about him only lasted, no kidding, like 2 minutes. The rest of the phone time, which was more than 2 minutes, were asking me characteristic questions. For example, what was my age? Where did I live? No kidding. I don't remember what specifically they asked, but they asked so many oddball questions. They could ask, hypothetically, how many TVs do you have in your house? What news stations do you watch? Who did you vote for in the last election? Do you attend church? Do you not attend church? Are you married? Divorced? Because what they're doing is, because what you can do also is with that data mining, you can turn around and now say, hey, out of these 1,200 people, we found out that people who own 5 microwaves or more voted for Gary Johnson in the last election.
Who would own 5 microwaves?
I'm just using it as an example. All right. So we can actually, so great example. You guys realize that Facebook, Snapchat, Instagram does that to you already, right?
Yeah.
Really?
Yeah.
I didn't know that.
Yeah.
That's why on your story feed, they show things that are interest.
So yeah, that's what the algorithm does. So what they're working right now is they're using statistics like that. They're data mining. Data mining, by the way, is all statistical analysis. That's all it is. All right. So what they're doing is they're taking all this information. So for example, they can look at Nick's Facebook or Instagram and go, okay, he's tagged himself in 80% of male pictures. His friends are male. They posted pictures. He lived in Baltimore before he got to Germany. We noticed that he likes these movies, which tend to be male stars, which might be, no kidding, which are primarily action movies, which are primarily this, you know, they can get down to nitnoid details. Remember, again, go back to the example with the body wash. They can identify one characteristic and they can come back and identify way more characteristics.
That's scary.
All right. Now you have to ask yourself, what was that?
Good, dude.
So
Makes sense.
it's literally trend analysis. That's really what it is. We'll talk about that. Trend, again, I mentioned we did the shampoo, or sorry, the body wash example. Trend. Simple trend is what is the way things are progressing, or which way is the data pointing. Okay? 50% plus 1, I argue, is a trend. So that's now telling me half the group plus 1 is doing something, that's a trend. Okay? It's not necessarily an accurate description, but yeah, that's how it works.
Okay.
Can I
All right? Oh yeah, sorry.
That makes perfect sense.
All right? There we go. Yeah, no, sorry about that. All right. All right. Any questions with this logic right here? That is the fundamental reason for stats. We don't go out and ask everyone, so we need to do it a quicker, more faster method. The key being, the sample has to match the population as much humanly possible. That's why I tried to draw it at least the same shape, but you'll notice the color is different. I did that on purpose.
Because it's a different number.
Yeah, that quality doesn't match. Okay? All right.
So have a big population, grab a section of the population.
Yep. So a great example, you go out and ask people, hey, we want to kill kids
A lot of
under the age of
people
5.
feel okay with
Now, if
this.
we go to New York City and ask all 1,200 people in New York City versus going to the great state of Wyoming and asking all 1,200 people there, we're probably going to get what? Different answers. Exactly right. All right? Because there's only 500,000 people in the entire state of Wyoming.
Because if you go to somewhere that's like highly populated and crowded, then they would be okay with getting rid of people. But if there's like an area that isn't highly populated and overrun with people, then they would be like, why do we need to?
Wait, you said 500,000 in the entire state?
Yeah.
Entire state of Wyoming.
There's even less in Alaska, and Alaska's the biggest state.
Yeah, Alaska has
What's the living in Alaska right
the lowest population density.
There's like 600 people.
All right. So that is the basic foundation of all the things that we're going to talk about when it comes to stats here. Okay? Is, again, identifying samples that match the population, ensuring that the quantities are there. The qualities are there. All right. So we look at statistics. So statistics just allow us to allow us to look at qualities, allow us to look at numbers, characteristics, and then come back and analyze across. So when we look at our data, what is data? And that's not the robot from Star Trek. All right, what is data?
Information.
Okay, yeah, that's a good way to put it. Information. Information that you have collected, however you've collected it. Okay? Data, yes. Okay? So with that data can be both descriptive there we go, and inferral. Descriptive and inferral, if you will. In meaning you are inferring something. Derek, what's it? Read out loud what it says descriptive. It's on the bottom page there on the right. Midway towards the top.
Descriptive statistics
Yep.
are used to collect, organize, and present data.
Okay, and what's inferral?
Uses information about a sample to say something about a population.
Okay, very good. So with stats, that's what you're doing. You go out and collect, that's descriptive, or what you're doing is you're inferring about the population. All right. Data in itself can also be qualitative and quantitative. All right. What's qualitative data?
of data.
Yeah.
Well, I'm assuming since qualitative is off of quality.
It is. It's a quality. Okay, so then what's quantitative?
A set amount.
It's what?
A set amount.
It is an amount. It is a numerical response. Okay, so for example, if I give you, I have a survey that goes out and asks, what hair color do you have? The responses are going to be what?
Different.
Okay, well, what is it? What are some examples of responses?
I guess some people would say black because normally that's an option for brown. Brown, blonde, red,
Okay,
brunette.
okay. Now, those responses would be what? Qualitative or quantitative?
Qualitative?
And why is that?
Because it's a characteristic.
Yeah, it's a characteristic. It's not a number. Okay? So, like if I ask you, what color car do you have? Okay, at the end of the day, I can add up how many cars were red, but I can't average red, blue, and green. The colors, right?
Yep.
Why? Because what happens with it?
It changed.
Exactly, it changed the characteristic, which means nothing. Okay? So again, qualitative is a quantity, meaning your responses are going to be something that is not a number. Quantitative is. So if I ask, how many speeding tickets have you had? 1, 2, whatever. That is a number. That is a numbered response, meaning that we can just simply run mathematics on those numbers. We don't have to convert anything over. Okay? Qualitative, quantitative. Remember that. That is importante. All right, the rest of what we're going to focus on in section 1 is what we call frequency distributions. All right? Frequency distributions, okay? Imagine for a second, let's do this.
Sorry.
Yeah, I wonder if there's a data set I can use. So frequency distributions, okay, is one method that we can use to take a data set and arrange it either in a table or in a chart or a graph that explains a set of data. Okay? Because again, we want to characterize that data. Yeah, you're exactly right, Nick, like a histogram. Exactly right. So the idea of, so for example, if we take on page 327, the top it says, consider years of education of a group of young adults. Okay? And it gives how many years of education? 12, 10, 15, 12, 15, 13, etc. Okay? And then right below it, it says the frequency distribution is as follows. It says years of education, and what they've done is they've set up 10, 11, 12, 13 through 16, and then it just went through the data set and counted how many people had those many years of education. All right? So it went through and counted it and put it into a nice little nifty little column right there. Simple as that. Okay? Now, when it comes to frequency distribution itself, at the top of page 328, it shows you that same table in a chart format. All right? So in this case, years of education is on the x-axis, the number of responses is on the y-axis. So we go back to our table, and it says years of education. 10 has how many? 1. So then we look at our chart, the response is 1. 11 has 3. And then we see at number 13, we have a peak. Goes to 5. Yeah, very good. Okay? Etc. Below it, it says, there's another one. It says, they have the polygon method. Okay? It's the exact same thing as the chart, except it's not bars, it's dots, and you connect the dots. It's the exact same concept. Okay? Let's do one of these for an example we'll go through real quick. On page 330, it says, number 7. 30 families were asked how many electronic devices, tablets, cell phones, and computers they have in their home. The number of devices for each family is listed below. Okay? It's each listed below.
So wait, how can you tell which one's which?
What do you mean?
Like which ones are tablets?
It doesn't care. It's just asking how many electronic devices. That's all it's asking.
Okay.
Good question. All right. Nick, you're going to read these numbers out to me.
You might wanna,
I'm ready. Hold on.
there's 10 columns. Or in a row.
Okay.
And 3 columns.
So there's 30 total.
Yeah.
That's what you're saying. Sure.
Yes.
Okay. All right. I'm ready when you are.
3,
Okay.
5,
Okay.
2, 6, 1, 3, 3, 6, 4, 5. And then, there you go. 2, 3, 5, 4, 6, 3, 5, 5, 2, 4, 8, 4, 8, 8, 3, 6, 5, 6, 5, 4.
All right. Whew, excuse me. All right, so here's our set of data. All right. So it's asking us to build a frequency distribution, I believe.
Yes.
All right. So we got to do one of two things. We have to, in one column, we have to put our quantity that we have, our quality. And then the second column is the response. So in this case, it's tablets or electronic devices. And this is our numbers in-house. All right. If we look at our data set, we start with, do we have any answers that are 0?
No.
Nope. We have answers that are, let's see, what is our range of answers? 1
1 to 8.
through 8. Okay. So we'll come over here. 1, 2. So that's our range of possible responses. Now we go back and we count them up. So how many households said they had 1?
1.
Just 1. Mark that off. How many of them had 2? Now we'll go through. 1,
3.
2, 3. Anyone else see any more?
No.
Okay. And I put an empty 3 over here. How many of them said 3?
6.
Yep. All right, 4.
5.
5.
6. No, 7.
1, 2, 3, 4, 5, 6, 7. Okay. 6.
4. No, 5. You're right.
Okay. Next. 7.
9.
None. Ooh, there. Okay. 8.
2. 3. Oh yeah. All 3 of them are in the third column.
Okay.
Top 4.
When we're done, we said we should have how many total?
30.
30. Okay, that's a frequency table, frequency distribution. That's all you're doing. Left column, what's the quality? So maybe how many have red hair? How many have blue hair? How many have no hair? Okay, and then on the right column is, no kidding, what are the responses you got for each quality? Okay, is that up to 30? Is that what you're adding up?
Yes.
Okay, perfect. And then how you now you can go make a chart. On the x-axis, we come in and go, okay, 1, 2. All right. Then we just line it up. And again, these are qualities. So these are electronic devices. Number of electronic devices. So this would be response. or number of houses. Okay? So number 1, those house we said was 1. Yep. We do 1 of 2 things. We draw the bar, we can do the dot, however we want to do it. Number 2 is 3. 3 is 6.
So after you do this, you put it in a bar graph?
Yep.
Okay.
So it's either a bar or free.
Yep. You can come in and connect the dots.
Okay.
And you go logically to its end.
So it doesn't matter how you.
Nope, your choice. I prefer the bar. Okay. Any questions on this? Remember, when 8 times 7, it's down here at 0. And it goes back up to 3. And so forth. All right. Any questions on frequency distributions? Again, the method again is look at your data set, determine the range of possible responses, and then the number of responses, and then plot it at the end.
Wait, question.
Yep.
On the chart, 4 doesn't have anything on it, but on the list, whatever.
Because I didn't fill it in. I just said logically you would fill it out the rest.
Oh, my bad, I didn't do that. I'm sorry.
Because you're listening to something.
Yeah, I'm listening.
Impressive. This isn't even chicken. Staring chicken.
What?
I don't know, he's just staring at me. Like awkward.
I thought that was a chart.
Uh,
So when you did it, we kept staring at each other off.
All right. Any questions on this?
Me.
All right.
Makes total sense. Perfect.
All right. All right, there's 2 things we'll talk about and we'll call it a night. How's that sound? And it's going to be really quick. So my years of teaching stats, this is not in the book. But when it comes to stats, statistics are trying to answer 5 questions. Or if I get a data set, whatever that data set is, we can look at the 5 characteristics of that data set and it will answer, it will help assist answering questions. Okay? But these 5 characteristics will explain any data set. Alright? CVDOT, center, variation, distribution, outliers, and time. Alright? Not in the book, but this will explain, I think, things a lot better. Okay? So I have a data set. Went out, collected data. Okay? Hold on. Derek, what was the last movie you saw? Okay, bad question. Nick, what was the last movie you saw? In the theater.
In a theater?
In a theater.
Oh, then Infinity War.
Okay, so Infinity War.
Yes.
Let's say you magically go stand outside the theater all day.
Well, I did.
No, I mean not for a ticket.
No, I was wrong. It
No.
was The Incredibles 2, actually.
Oh, okay. How was that? Is that
It
good?
was so funny.
Okay. I haven't seen it yet.
Oh, my dad was more excited.
Oh, your dad was?
Yes.
What?
Oh, no.
Ah.
Nice. You're like, Dad, this sucks.
Well, I've watched it too many times.
Oh, the
Once
first
every-
one? Yeah.
Once every month, and I'm like, enough.
Yeah, you guys grew up with The Incredibles.
Yeah.
Because I was in high school when that came out, so.
That's my jam.
It came out.
Yes, my dad loves
It
it.
is
Okay.
the greatest movie ever.
Your dad's about my age, right?
What?
Is he in his 30s?
No, he's 45.
Oh, okay, so he's 6 years older than me. Okay. But he was at the age where he was like, yeah, this is a cool one to watch. Okay. But, so imagine you go stand outside the theater all day. Movie comes out, first movie screening to the very last one for the day. All right? And you ask, did you like this movie? And you're just going to ask the first 100, we'll make it 200 people you run into. Okay? I've collected the data. Now I'm going to go home and now I'm going to look at the data. First, if I'm going to describe, this is the key phrase here, if I'm going to describe the data, these are the 5 things that you use to describe the data. The center point of the data, the variation inside the data, distribution, outliers, and time. Okay? Center, variation, distribution, outliers, and time. I'm going to skip straight to the bottom, number 5, time. Okay? I've gone to a movie theater, and we'll make it Infinity Wars. Okay? You gotta go to a movie theater. If I stand there all day, how does my audience look and differ throughout the entire day? Or actually, let's do this. Let's change it, because everyone here works on base. Perfect, except for Nick. All right? I go to the commissary, and I am a bagger at the commissary. And I stand there and I look at 200 customers that come through the day. We'll make it a Friday. Okay? How does my audience and or sample change throughout the day? In the morning, who primarily goes to the grocery store?
Old people.
Older people. Or people on the go. They need to pop in and go out. That's it. They're quick items. They're not going to buy anything. Right?
School kids that drive.
Okay. Okay. Who goes to the commissary at 2:30 p.m. in the afternoon?
Parents with their kids?
Parents and kids, yes. Who goes during lunchtime?
All the working people.
All the military members go to the commissary during their lunchtime. All right? I'm assuming that's the same over here at Panzer?
I have no idea.
D. Is that true?
I don't know the answer to, so it's not my answer.
And I said, I'm assuming that the commissary is packed full of military members at lunchtime?
Yep.
Okay. So yeah, your crowd changes.
During lunchtime, define lunchtime, like 11 o'clock.
Yeah, 11 to 1.
Military students.
Okay.
Yeah.
And then in the afternoons, parents, families.
Parents, teachers, and military that you set off work.
Okay, very good. So time can dictate how different your answers can be. So for example, if I go out and ask 200 people, let's say I ask 200 people 5 days before the FBI releases a report on the the Clinton campaign, you're probably going to get different results than you would 5 days after that FBI report was released. Okay? Meaning that there are factors involved, and the time in which you took those samples can cause an impact on the solution. Okay? If we look at the rest, center, variation, distribution, outlier, we're looking at other things that distinguish the data. What is an outlier?
Outlier.
A set of specific data.
And that was probably one of the most generic answers I've ever heard. Say that again? Now I'm sitting here analyzing what you said. I was wrong. It was wrong right off the bat, but now I'm actually thinking about what you said.
A set of specific set of data, set amount of data.
Yeah, that is one of the most generic answers I've ever heard. Seriously. It's some things, you know, the things, such as the South Africa, the Iraq. What is an outlier? Have you guys heard outlier used?
What?
Oh, it's okay.
It's a book?
No. I'm saying it's kind of like English. It gives you the specific instructions to follow.
Nope.
Or
So let's analyze the word. Outlier. And it's not L-I-A-R. It's L-I-E-R. Okay? An outlier is a data point. Is a data point. So think of it as a bullseye. That is so off the target, we don't even consider it. Okay, so great example. If you go take a college class, and there's a 65-year-old woman in the class, okay? What's the average age of a student in college? probably 19, 20. Assuming that every grade, freshman through senior year has the same number, and there's probably less seniors than freshmen, probably around 19, 20. All right? But the older you get, well, there's really no one under 18. There might be a few, right? But the older you get, you're going to see what? Less and less people. To the point where you get so far away from 19, you sit there and go, yeah, a student here, she's 65. That would be an outlier. Something that is so distinguishably different, it throws the rest of the data off. Okay? Outlier, remember that.
Outlier.
Something that is so distinguishably different that you have to throw it out of the data set. Okay? The rest of it described, think of it like this. Some other things to talk about when it comes to center variation distribution. We'll talk about this in a second. What is accuracy? And what is precision?
Accuracy is like in the area
Okay.
of whatever you're graphing or whatever data.
Okay.
And then precision is within the range that you want it to be. Like, I don't know how else to describe that.
Okay.
Like, let's say you want to score 5 goals. You shoot 5, but you only need 2, but the rest were, in soccer terms, it would be on point or within the area of the goal.
Okay.
So let's say it hits the crossbar. That's still within the range, but it's not counted as a goal.
Okay. So an let's go back to accuracy first. What is accuracy?
However close it is to the target.
Okay. Exactly right. Did I hit the target, yes or no?
No.
Okay. Accuracy. Did I hit the target, yes or no? Okay. Whatever that target is. So let's say you're running an experiment. Okay. And the results say that whatever it was is this. Okay. And that's what it's supposed to be. That is what we would call being accurate. It is like the bullseye, meaning every time you shoot, when you shoot, you hit the center point. Okay? Or if you're designing something and you need it to be this, it is this. That is accuracy. Did I hit the target? Precision has nothing to do with hitting the target. Precision is how many times did I repeat my performance? Okay? So think about it like this for a second. So draw it up here. Let's say I get 5 shots, okay? And my 5 shots look like that, meaning they're pretty much grouped around the center. That is what we would call, that is something with high accuracy, okay? High precision may look something like this, where your shots may be all 5 down here. Is that accurate? Exactly right. That is super precise. Yep, we all got 5 in the same area, but it's not the right area. Okay? Yeah. So you can have accuracy, but you may not have precision. So speaking of, like, let's say you have a gun that's on a spool or like on a stand or something like that, and you got it perfectly centered, everything, pull trigger 5 times. It's going to have great accuracy, great precision. Let's say while we look to the side, a kid comes up and knocks it. Where now we get horrible accuracy, but we get great precision. Meaning, we all hit in the same spot. Okay? All right. We'll stop there for tonight. We'll come back tomorrow. Tomorrow night, we'll be here at 6:30. We'll finish out chapter 8. What I need you guys to do...
Tomorrow night's the makeup, right?
Yep, and Saturday.
So Saturday.
We're go on Saturday. So we will not have class Tuesday or Thursday next week.
Yeah.
So what I need you guys to do is post all your quizzes, get started on the quizzes. All the information's up on the website as well, class website, and whatnot.
The last
So,
due date is.
everything needs to be done, turned in to me by 23:59 Thursday night.
20:59 Thursday
So
night.
that's
Isn't
so
that the
1 in the
last-
morning, or 1 minute before 1 in the morning, right?
1 before midnight. Yes.
Question.
Go.
Isn't Thursday our last class?
We-
Technically last day?
We are not having class.
So we're not having class for week 8?
No, because we're making it up on Friday and Saturday.
When do we return to the finals?
Their final is going to be provided online as well. And you'll get
He'll probably send us an email.
Yep. And I will actually upload it after a class on Saturday.
Oh,
Alright, cool.
Alright. Any questions?
I won't be able to be here on Friday. My parents will not be here.
Yeah, no worries. So same thing, I'm gonna record it. I'll throw it up online.
Okay.
And then you can just watch it.
Alright.
That's cool. I'll make sure I point to the camera. And be like, Derek, are you watching? Alright. Do you guys got any questions?
No.
Okay. I guess I'll see you guys tomorrow night. I'll probably upload it right as soon as we're done with class Friday night. Cool.
No.
Awesome.